Hi everybody, this video is on the Portland pulse motor. The Portland pulse motor has three main characteristics. It has an oscillating transistor circuit, it has magnetic bearings, and it has solar recharge. I'd like to thank these people and many others on YouTube that have given me ideas and inspiration to build this motor. There were quite a few failures and variations along the way. Here's a 5-pole rotor, which is actually easier to make because it has more pulses per revolution, but I like the slower speed and the looks of 3 poles. Note the yellow arrow, which shows the shaft of the rotor is constrained in the center of the ring magnet by a bar, and I'll show you later why that was a bad idea. Here's the wiring schematic and the circuit board layout. This is the resource that I used to draw up the circuitry, generate the Gerber files, and have the circuit boards manufactured. And about a week later, these are the boards I received. This was actually one of the hardest parts of the project, creating a cavity for the coil and the electronics. The coil has to be no more than about an 1/8 inch from the magnets. Less is better. And if you had a milling machine or if you're really good with a router, this would have been a lot easier, but it shows it will work. Note that there's a metal insert on the left and the right. I'll show you later why those are important, the threaded metal inserts. Here you can see the electronics tucked into that cavity. The coil is 2,000 turns of 34 gauge wire. I'll show you how to do that very easily a little bit later on. The vertical brass rod comes from the toilet department of the local hardware store. It has 1/4 inch 20 thread on the bottom that goes into those inserts that I was talking about earlier, and that allows for it to be adjusted in the up and down direction. And here you get a good idea for how close those magnets come, the rotor magnets come to the coil on the undersurface of the wood cavity. It's been running about 2.5 years continuously on that one nickel metal hydride battery, so the solar charging seems to work pretty well. So this is the magnetic bearing portion, and it's really fascinating. The large ring magnet is held in place by an interference fit with that piece of brass strapping. I soldered a circular piece of strapping in a circular manner around the magnet, soldered that to the vertical brass rod. So now that ring magnet is attached firmly. Next, I slid a disc magnet with an 1/8 inch hole in the center onto that white garolite shaft, and I'll show you where to get that later. And you have to position, this is fiddly, but you have to position that smaller disc magnet in the left and right direction until it just barely allows the shaft to be pushed in the direction of the orange arrow. So depending on your north-south orientation, you'll have to go back and forth and fiddle with those. There's two of them, one on the left and one on the right of the rotor. Once you have it so that it is giving very slight force in the direction of the orange arrow, you adjust the screw where the red arrow is to minimize that. If it becomes too small, the shaft will just shoot out to the left. You want it to just barely press against that screw. And the amount of friction that is there is unbelievably small because of that magnetic bearing. The only thing that's touching is the very tip of that garolite shaft, and that is touching with very, very minimal force. Remember earlier I said it's not a good idea to constrain the shaft with a fixed point like I had in the prototype. Here you can see with the yellow arrow, I took a piece of 1/4 inch stock and heated it up, bent it, and fabricated a little L bracket off of that the beauty of that setup is that you can adjust it up and down. See, the weight of the rotor and the shaft and the two disc magnets means that the shaft is not going to be naturally centered in the center of the ring magnet. Gravity is going to make it just a little bit lower than the center. So it's really hard to figure out where that's going to be, but with this magnetic setup, you can just move that piece that the yellow arrow is pointing to in an up-down position to minimize the friction and get it so that it's sitting, get it so that the shaft, the Garolite shaft, is sitting right in the middle of that little dimple that I drilled into the end of that screw that the red arrow points to. The blue arrow points to a collar that slips over the other side of the thread, the adjusting thread, and that's just to attach the wire, that black wire, to the grounding wire. And here's another view showing that grounding wire coming up and attaching to the shaft. So the reason you need the grounding wire is that I discovered that after this thing sits on a table and runs for a week or so, it develops this unbelievably high potential static charge. And if you walked more than a foot or so away, less than a foot or so away from it, it would arc and literally go right through your clothing and give you just a wallop of a shock. No, no, not really. Nerd joke, just kidding. No, it's just for fun. On the left, you can see that I used carbon fiber rod for the rotor arms, and I glued those to the magnets using a drill press to make sure they're perpendicular. There's a little brass sleeve that I fabricated in the final rendition that just made it look a little bit neater. I also, on the right slide, you can also see I used a template to make sure that the rotor arms were exactly 120 degrees apart. Okay, here's my way to make coils quickly. Go to the hardware store and get these parts, except for the straw. Next, put the screw in the drill and tape the loose end of the wire to the rotating chuck and just start winding. Add a tiny bit of epoxy as it goes. Before the epoxy fully sets up, the rubber washers can be peeled back. This particular coil has an excess of epoxy. In an effort to be more consistent, I went out and bought this little counter, which worked really well. The sensor was taped to the body of the drill, and then a magnet was attached to the rotating chuck. Every time the chuck came around, it would just trigger another count. It just looks really cool to have large diameter magnets with that magnetic bearing, and this is the only place I could find that had really good sized neodymium magnets. And this is where I found the Garolite rod that worked so well for the shaft. So there you have it, the Portland pulse motor. Thanks for watching the video, and I hope that you build one of these motors. They're a lot of fun.